Good morning. So today we're going to be learning about sine law. All right. So first of all, let's recap on what you need kind of before going into sine law. So generally, when you look into trigonometry, you're looking at sine, cos, and tan. And what that means is there's a square in the triangle, which means that one of the sides is a 90-degree angle. So generally, you only looked at triangles that have a 90-degree angle, essentially. So here we have a triangle. We have an opposite side of 12 centimeters, an adjacent side of 23 centimeters, and then I denoted just an angle there as theta. So let's write those in. When we look at these, you're trying to solve for an angle or another side length. In this case, we could solve for h using Pythagorean theorem because it's a primary um, triangle. But we can also solve for our angle, and so let's see how we would do that. So in this triangle, you notice that the given information is on the opposite side and the adjacent side of that angle. So you know you're going to have to use tan. And then you do it the following way. Tan theta is over A, and then you plug in the numbers, 12 over 23. But then you got to solve for theta all by itself. And how you do that is you do the opposite of tan, which is tan inverse, or tan to the negative 1. And you do it to both sides. Doing it to the left side would just get rid of that tan, and doing it to the right side gives you that tan inverse. So then we type it into our calculator and we get 27.6 degrees. You use sine, cos, and tan to solve right triangles, either their angles or their side lengths. Let's get out of the shallow end and jump right into the deep end. So we're not going to look at just right triangles anymore, or just the triangles that have a 90-degree angle, because there's so many more triangles out there. There's so many other triangles that don't have 90-degree angles. And so if you know how to use sine law, it works for certain triangles that are not 90-degree angles, so you can solve those as well after this lesson. So what is the sine law? Sine law is A over sine A equals B over sine B. And sometimes you can add C over sine C to the end as well. But generally you just use it with 2. Sometimes you see it with that C as well. Only one equal sign is what you use. So it's A over sine A equals B over sine B. So let's take a look at this. We have here a triangle, and in it has no square, so it's not a right triangle, and those three angles are different than 90-degree angles, which is the majority of triangles. One thing to note is you always need generally 3 pieces of information to solve any triangle. So if they give you only 2 or only 1, you know you won't be able to solve any triangle. So here I'll draw the 3 angles or the 3 side lengths. And a question will give you any combination of those. Sine law can only solve a certain type of this triangle. But probably the most important part of sine law here is seeing that big letters mean angles and small letters mean side lengths. And one thing that you have to do is the same letter has to be straight across from the same letter. So here we see A is straight across from little a, and it would have to be the same with B and C as well. It doesn't really matter what angle you put A, B, and C on. It just matters that the little letter and the big letter are straight across from each other. So if we take a really quick look at all the different combinations of 3 pieces of information that you could have, you see that sine law is 3 of the 6 cases. So you'll be able to do half the types of triangles after knowing sine law today. So let's look at an example. There's 3 types of examples somebody could give you for sine law. So let's look at the first type. This is called an angle-angle side triangle, but that's not really the important part. It just is important because we see that there's an angle across from a side length, the 50 degrees across from the 12 meters side length. So let's just write letters on the angles that we know, A and B. And so we're going to also write the corresponding small letters across from the A and across from the B. Okay, we don't know what little b is. That's kind of the important piece. That's what we're going to find out. So if you know a and little a, then you will be able to find that little b. So let's try it out. So we know sine law is a over sine a equals b over sine b. It doesn't really matter what order you put the letters in. So here I wrote b over sine b equals a over sine a. It's okay if it's switched like that. It still works. You just need the b to be on the same side as the b and the a to be on the same side as the a. So we're going to solve for b. So you can see that's why I wrote b first, because that's the one I'm solving first. So here we have b over sine b equals a over sine a. And if we look at our triangle, what's big B? It's 30 degrees. What is little a? 12. And what is big A? It's 50 degrees. So then we fill those in, and we have to solve for b, which means get b by itself on one side of an equal sign. Okay, so that sine 30 on the bottom is a problem. So we got to get that to the other side. So how we do that is we multiply by the whole of sine 30. Okay, we multiply it onto both sides, and that will kind of make the left side disappear, and we'll add it on to the top of the right side. So we end up with 12 times sine 30 divided by sine 50. So let's type that in our calculator, and we get 7.83. And since it's a side length, since it's a small letter, we're going to write 7.83 meters. Okay, not degrees, but meters, because it's across from that big B. Some questions ask you just to come up with the side length and then you're done. Sometimes they ask you to solve the triangle, which means come up with the other two side lengths as well, the C and the little c. So how do we do that? Well, I'm going to show you this important rule number 1 to do with all trigonometry, and all three angles of any triangle will always add to 180 degrees. So this is a really important piece of information. You usually always try to do this if you can. So since we already have two angles, we have 50 degrees and 30 degrees, we know we can find the third one. All three angles have to add to 180 degrees. So we're going to go 180 minus 30 minus 50, and that'll give us our third side. So we get 100 degrees for big C. Now we can see that we have the angle across from little c. So let's use sine law to solve for little c. So it's going to be the same way as we did it before. It's c over sine c equals a over sine a. Note that the same letters are on the same side. And so we fill in the letters. Big C is 100 degrees. And here we're using a over sine a, so it's going to be 12 over the one across from it, sine 50. Again, we got to get c by itself, so we got to multiply by that sine 100. So we're going to multiply that to both sides, which effectively disappears the one on the left and adds it to the top of the fraction on the right. So let's type that in our calculator. 12 times sine 100 divided by sine 50, and we get 15.43 meters. Okay, so we were able to solve every piece of information on this triangle using sine law and that special rule number 1 too. Now let's look into example number 2 out of 3. So here we have a triangle that's called an angle side angle triangle. This is because you have an angle, then a side, then an angle on the other side of the side length. So we have a 40-degree angle, 70 degrees, and a 12 feet side length in between them. So let's draw kind of our opposites, and what we notice is that in this triangle that there's no opposite side length to a known angle and no known angle opposite to that side length. So how are we going to do this? This one's a little bit trickier, but what you have to bring into, again, is rule number 1, is that the three angles of any triangle is going to be 180 degrees. So this third side is going to be kind of 180 minus that 70 degrees and minus that 40 degrees. So you know that it's going to also be 70 degrees due to the fact that we already know two angles. So we're going to put that in first, and now we have an angle across from a side length. Okay, so we're going to denote the different angles, A, B, and C. It doesn't really matter where they go. Again, it matters that the same letter is across from the same letter. So we're going to make big C 70 and little c 12. So now let's try to find what side length B is, little b. So let's use our sine law. So we're going to do it the same way that we normally do it. We notice big B is 40, little c is 12, and big C is 70. Again, we multiply by sine 40, and we end up getting 8.21 feet. So now we have solved that, and the only last piece of information that we need to solve for is little a. So we can do sine law again to solve for little a. So it's going to be the same process. We're going to multiply by sine 70, and we'll end up with 12 feet for little a. Now let's jump into example 3, and the last type of sine law example that you can get, and it's an ASS type of triangle, or also known as SSA. And this is the fact because you usually have an angle and then a side length next to it, and then a side length next to that. Here we notice we don't have an angle between the two side lengths, but we just have angles side side. So we have this here. One thing to note is the 20 degrees is straight across from the 30 degrees. That's what we want, and we know we can solve it using sine law. So we know we have the 18-meter side length, so we're going to need to know what the angle is across from that. The difference with this one here is we don't know the angle across from it, so we have to solve for the angle this time, not the side length, because we know two side lengths, so we have to solve for the angle this time. So let's write in our letters. I'm going to write big A for the 20 and little a for the 30 meters that's across from it. And then I'll call the 18 meters little c this time. And that'll be 18 meters. And across from that, we'll make it big C. So here, this time, we're trying to solve for big C. So I always write the thing I'm trying to solve for first. So this time, it's different because we're not going to write the sine law as a over sine a equals b over sine b, but we're going to write sine c over c. So this time we're going to flip the whole sine law so that your sine c is on the top this time. You're allowed to do that. You're allowed to flip fractions as long as you do it to both sides of the equation. So here we have sine big C over C is equal to sine big A over A. So now let's fill in our information, but now we have to solve for this big C. Okay, we have to get big C by itself on one side of the equation. So let's get rid of that 18 on the bottom. And how we do that is we multiply by 18 to both sides. This will get rid of it on the left side, and it's going to multiply it on the top of the right side. So now we have sine C equals 18 times sine 20 over 30. C is still not by itself. So how do we get C by itself? We have to do the opposite of sine. The opposite of sine is that sine inverse button, or that sine to the -1 button. So you're going to have to do that on both sides of the equation. That'll get rid of the sign on the left side and add it on, add a sine to the -1 onto the right side. So we end up getting C equals sine inverse of that 0.205. Okay, and that 0.205 is just the 18 sine 20 divided by 30. So overall, we end up getting 11.84 degrees for that C side. This was a bit of a trickier example. You could solve the rest of the triangle if you want. We'll do it really quickly. You can get that third angle by using rule 1, and you'll end up with 180 minus 20 minus that 11.84, and you'll end up with 148 degrees for that big B. And how would you solve for B? Well, you would just use sine law again. So I would try it out. Here's the answer right here. You would get 46.3 meters as that B side length. And one thing to note is this ASS type of triangle, you probably don't have to worry about quite yet, but eventually you'll learn that there's an ambiguous case to these types of triangles. This brings us to the question, why is it called sine law? It is called sine law because when they first started this, they didn't know what sine law, so they wanted to solve this triangle out. They had their 3 pieces of information, and so how did they solve it? All they knew were right triangles. So they put this dotted line in so that they really divided this big triangle into 2 smaller triangles, 2 smaller right triangles. So using that, they can find the length of that dotted line by using primary trigonometry. And so it turns out that you use sine to find that dotted line, or that first x. It's not tan and it's not cos. It just happens that it's an opposite side and a hypotenuse that you use. So you end up using sine. And then after you find that dotted line, you end up using sine law or sine again to find that second x, or that top angle. When you're using sine law, you're intuitively just doing this without knowing that you're doing it. You're using sine twice to solve that top angle. Why learn this silly sine law? Why are we, well, one reason here, which is pretty cool, is you could have a tree and then a river, and you could be standing on the opposite side of the river, and maybe you don't know how to swim, so you can't get across, and you want to find out how tall this tree is, because you really have to know how tall this tree is. Using sine law, you will be able to find out how tall this tree is without even crossing the river. All you would need is something called a clinometer, which will tell you that kind of the angle with how high you see the top of the tree. Okay, so now you're standing on one side of the river, and you find out that it's 40 degrees up to the top of the tree. And then you walk 20 meters closer to the tree, and then you find out that it's 60 degrees from there to the top of the tree. With those three pieces of information, you can find out how tall this tree is. And what you do is you first have to use rule number 2, which says that if you have a straight line and something intersecting in between it, the two angles on either side of that intersector have to add to 180 degrees. So using this, we'll find out that this is going to be 120 degrees there. Or using rule number 1, we can find out that this third angle is 20 degrees up there. And now we can use sine law to find out what x is. Okay, so we can use sine law to find out what that x is, and then we can use the 60 degrees with that x to find out what our exclamation mark is, using that primary trigonometry at the end. So a little bit complicated, but you can use it to find kind of cool pieces of information that you'd never think was possible. Another thing you can do is you can build a creative shelf. I've tried that before, and I've happened to have to use sine law in building it. Another thing is if you go on to chemistry, sometimes you do things where you're not expecting to use trigonometry, and they just naturally come up, and you have to use it to solve your problem. So in chemistry, you might have to use sine law to find the angles of certain atoms. Or if you're in astronomy, you can look at the stars, and you can figure out maybe how far away the stars are using trigonometry. So they come up in different spots where you wouldn't think they would. All right, so let's take a quick minute just to recap what we've done today. Number 1, so always try to get that third angle if your triangle gives you 2 angles by using rule number 1. Part 2, if you happen to have 3 pieces of information and you want to find a side length, what you're going to do is you're going to write a over sine A equals b over sine B and go from there. Number 3, if you want an angle, if they give you 2 side lengths and only 1 angle, this time you have to flip it and you have to make sine C over C equals sine B over B. So it's slightly different version. Number 4, if you have 3 pieces of information and you have a side with a length across from it, that means you're going to have to use sine law. Maybe in the future we're going to see cosine law, and you're going to see maybe different examples where you don't have a side length across from an angle. But whenever you have a side length across from an angle, use sine law. And just to finish off here, what again are the types of triangles, in case you're wondering, that use sine law? Angle side angle, this type of triangle. An angle angle side triangle, that looks like this. Or an angle side side triangle. This third one is a bit special because it can be ambiguous, but this you usually learn later. All right, thanks. Let me know if there's any other questions in the comments below or anything else that you'd like me to cover. Thanks.